Electrotherapeutic stimulation system. Let's understand some basics about different types of currents we have in our electrotherapy. Constant current, wherein the devices that produces constant flow of current, that is constant amplitude with a specific range of impedance. Constant voltage are the instruments that provide constant voltage volts in a specific range of impedance, that is current flow is indirectly proportional to impedance. And these are to maintain the voltage output of a device. We have direct currents, or known as plain direct current or galvanic current. These galvanic currents are continuous direct currents. They flow unidirectional. They can be reversed or interrupted or ramped. Galvanic current are defined as direct currents having no pulses or waveforms, hence no parameters are there. The major physiologic response to direct current by the body is electrochemical changes. And that happens at the cellular and the tissue level via change in pH of the skin underneath the electrode, causing reflex vasodilatation and thereby increasing the arterial blood flow to the skin directly. Then we have interrupted DC, interrupted direct current, also known as Faradic current. These are the currents with short duration with pulse of 0.1 to 1 milliseconds and a frequency of 50 to 100 Hz. They help stimulate the motor and sensory nerves, thereby stimulating innervated and the denervated muscles. What are its uses? So it helps in facilitating muscle contraction, to re-educate a muscle action, training a new muscle action, to improve venous and lymphatic drainage. It helps in loosening the adhesions. We have TENS, transcutaneous electrical nerve stimulation, which is shown to produce pulsed rectangular waves. We have different types of these TENS. There are high TENS, low TENS, burst TENS, acupuncture type TENS. So the high TENS works on the pain gate theory, and person feels a tingling and pins and needle sort of sensation when the electrodes are put. The width being 100 to 300 microseconds, 100 to 150 Hz of frequency, uses 12 to 30 milliamps of intensity. The low TENS works on endorphin enkephalin theory. It produces a sharp sensation. The width is 100 to 150 microseconds and the frequency being 1 to 5 Hz. Intensity is more than 30 milliamps. Wherein the burst TENS works on activating the physiological blocks, thereby reducing the pain. So uses 150 to 200 microsecond of pulse duration, which feels pulsating anesthesia types. There is acupuncture TENS that uses high intensity low frequency current. Intensity being 30 milliampere, frequency being 10 pulses per second, and the pulse duration being 100 to 300 microseconds. We have IFT, interferential currents, that uses two medium frequency currents to produce a low frequency current effect. Principle being simple, that is interference effect. What is it now? So when two medium frequency currents crosses the patient's tissue, there is channels of different frequency that produce a small beat frequency. Usually about 4000 Hz and 2000 Hz are seen. So without unnecessary skin stimulation, these IFT helps to produce the effects only under the tissues that is required. We have diadynamic currents. These are modified pulsed currents, usually having sine waves. The carrier frequency of 100 Hz, that is either half or fully rectified waves, results into a pulse of 50 pulse per second in terms of monophasic, 100 pulse per second in terms of diphasic. We have HVPC, high voltage pulsed currents. These provide monophasic pulsed currents. They have shorter phase duration and a high peak amplitude. Hence, this combo allows relatively comforting stimulation to the patient. It is seen to be efficiently exciting the sensory and motor nerve fibers and the pain conducting nerve fibers. Hence why the uses are in pain management to accelerate tissue regeneration in terms of wound healing. There are Russian currents. These are the continuous sine waves that outputs about approximately 2500 to 5000 Hz modulated to yield 50 bursts per second. Each burst is being a polyphasic waveform. This is a time modulated alternate currents and is used in pain management to improve the range of motion, to regain the muscle tone, to reduce the chronic edema. We have microcurrents. They supply monophasic rectangular waveforms having very low amplitude. Hence, this doesn't even activate our cutaneous sensory nerve fibers. So the patient doesn't perceive any tingling sensations. Frequency of these are 0.6 to 680 Hz and peak amplitude being 300 to 500 microamp.